So I am talking to you nowadays about data warehousing. In the previous class, I gave you the definition of data warehousing. I also talked about the various schemas which are used for storing data, and I also discussed about star, snowflakes and multi-dimensional cube on that day. So now from that point onwards I am starting further. In enterprise data models, there are actually 4 data models. These are categorical, exegetical, contemplative and formulaic. Categorical, exegetical, contemplative and formulaic. There is a little difference among these enterprise data models. The categorical model just gives the information about what data is available in the data warehouse. It doesn't tell anything further. The exegetical data model is a model which talks about the historical part of data. So it tries to find out what were the factors which led to the present problem. Every organization will have some present problem. The present problem could be less market share, less financial working capital, less number of footfalls in the mall. Any problem can be there. So what has caused this problem? That is answered by exegetical data warehouse model. The third is contemplative model. Contemplative model is very similar to the what if analysis in Microsoft Excel. In Microsoft Excel, if you remember, there is a what if button. What if? So let us say there is a complicated worksheet in front of you. The last line of the worksheet shows what is the net profit. So you would like to know how to change this net profit, how to increase this net profit, say by 10%. So there you enter the 10% increased value in the final profit figure and then specify which input cells you would like to change because of that. So it will immediately tell you that the profit will increase by 10% if you decrease the depreciation percentage from 5% to 2.5%. Some such answer it will be. So that is the what if analysis. That is a kind of analysis which is done in contemplative model. And the fourth is formulaic model. Formulaic model is also similar to what if, but with a little more refinement. So in this you can find out which cells will change by how much in order to get the required value in the final cell. So these are the 4 kinds of enterprise data models. Now I would like to talk about the 4 kinds of OLAP styles. OLAP stands for Online Analytical Processing. So for OLAP, there are 4 styles, and these are desktop style, multidimensional style, hybrid style, and relational style. So these are the 4 styles of OLAP. The first is the desktop style. In this, we don't keep any multidimensional cube. We don't even generate the multidimensional cube. We don't generate star or snowflake schema also. The OLAP is done directly on the relational database model. This is okay for small companies or for new companies where the number of transactions is currently very less, because this model involves more of querying and more of workload on the system. So here all the transactions like purchase, sales, payments received, these all have a date. For OLAP, we need summary data. Summary data is about product categories, it's about market segments, country of export, and most frequently, summary data will be about the financial year, quarters of the financial year, months of the financial year, and so on. When these are to be generated from the date of the transaction, it means a complicated query is to be done. Whenever many such queries are run on the RDBMS, the performance of RDBMS suffers. By performance I mean the search performance. As you know, for add record, modify record, delete record, for all these data manipulations, we first need to search. For add record also you need to search. A new record is to be added. Depending on how the original table is sorted, the new record has to go at a particular place. That search is required. For modification also, similar search is required. For deletion also, similar search is required. So search is the basic operation. By repeatedly running queries to get the financial year quarter or financial year month from the RDBMS, from the transaction date, it needs the slowing down of the search operation. So when the search operation is slowed down, everything in the RDBMS will work slowly. So this model is suitable only for very new companies or those companies where the relational database size is not very large. So for those companies, this OLAP style is okay. For other companies where the RDBMS size is very large, say for example Ola or Uber, the number of rides which are booked per day, they are in thousands,
Yes.
or they could be in lakhs also on some days. So here the relational database becomes humongous, very large. So in these companies, it will not be possible to do OLAP directly on the relational database model. Similarly, you could think of companies like Amazon or Flipkart or Instamart. These are all very fast moving companies where number of transactions are very fast every day, thousands of transactions take place. So in such companies, relational or desktop model will not work. The second is multidimensional cube. Multidimensional cube is the preferred method for all large companies.
Only large.
All large companies. So for Amazon, Flipkart, Ola, Uber, Rapido, for all these companies, multidimensional cube is the preferred model. In this, the data is kept according to dimensions. Dimensions can be many for data. Dimensions can be on product category, market segment, financial year. So on all these dimensions, the data is kept in the multidimensional cube. Now you will remember that on a flat screen, it is not possible to show more than 3 dimensions. But in software there is no such restriction. You can have any number of dimensions, 10 dimensions, 50 dimensions, 100 dimensions. So any number of dimensions can be there, and on multidimensional cube, lot of data analysis can be done online. The methods for data analysis on multidimensional cube is by 2 means. One is pivoting and rotation, and second is by slice and dice. So in pivoting and rotation, we pivot the cube or multidimensional cube or hypercube on one of the dimensions, and then we rotate it. Rotation is just like what you do on Rubik's cube in your toy shop. Rubik's cube is there. You can twist it in all the axes. So that kind of pivoting and rotation can be done for analysis. And second is by slice and dice. So when you cut a multidimensional cube along one dimension, you get a slice of all other dimensions with that one dimension fixed. So like that we can do slicing, and then you cut this slice into still smaller cubes, you get a dice. So slicing and dicing is another method. Of course there is a third method also, which is drill down. So you can drill down and find out what has caused a particular problem. So these are the methods by which analysis is possible on multidimensional cube. The third model is hybrid. The word hybrid means it's a combination of desktop and multidimensional cube. So it tries to balance the benefits of both, and in the process the disadvantages or drawbacks of both also come into this to some extent. So in this what happens is that we try to do the analysis on a metadata layer which is put on the RDBMS. Metadata, as you know, is data about data. Data about data means
Data about
data.
data about data.
Yeah. For example, there is a date column. The date column, is it DD, YYY, or is it DD, YYY? This is metadata. Then similarly for numbers also, metadata will be there. Number is an integer or a floating point number, double floating point number. So that is the metadata about numbers. And thirdly, about currencies. Now in RDBMS, always the currency will be that currency which pertains to the customer who has logged in. So if the customer is from India, we display the unit rates in Indian rupees. If the customer is from France, you can't display in Indian rupees. You have to display in France currency, that is euro. If the customer is from China, again you can't display either in euros or in rupees. You have to display in yuan. Yuan is the Chinese currency. If the customer is from Japan, you have to display in Japanese currency, that is yen. So in RDBMS, the currencies of prices are all different depending upon from which nation, from which location the customer is logging in. That is required in a RDBMS. But data warehouse is not for transactions, it is for analysis. So all the figures are brought into a uniform currency. This uniform currency will generally be American dollars because that is the most common universal currency. So all the figures are converted into the US dollar and then they are kept in the data warehouse. So this is how we use the hybrid model. As I told you, hybrid model tries to balance the advantages and disadvantages of both the desktop style and the multidimensional hypercube style. The fourth is relational data model. In this there is no separate cube. No separate cube is created. The analysis is done directly on the RDBMS as in the desktop. And second point that you have to remember is here the data remains relational. So there is no denormalization also. Denormalization is what? Denormalization is removal of relations by adding redundancy of data. So that also is not done in this. The data is kept relational, redundancy of data is not there, so complicated queries need to be run to get the analysis done. So these are the various ways for OLAP style. Now, DWH has two kinds of architectures. First architecture is two-tier architecture. Yes. And the second approach is three-tier architecture. So the difference I would like you to understand. In two-tier architecture, as the name itself implies, there are only two tiers. So first tier is the client application, which is nothing but the user interface. User interface means it will be an HTML page with DHTML built into that, cascading style sheet added into that, and it is linked to the database so that when you ask for a particular record or a number of records, those are displayed, and also when you make any changes in the form, those are also reflected back in the database. This is the client layer, and second is the database layer, which contains the actual relational database. Need not be relational, it could be non-relational also. The actual data store is linked to that. So this is a very simple architecture, but in this there is a disadvantage. The disadvantage is the user, the client, is directly interacting with the database. So when he makes a mistake, the mistake is reflected in the database, and repeatedly we have to find the mistake and try to remove the mistakes, which is not very easy to do. The second layer, second method is, the second architecture is three-tier architecture. In this, a third layer is added in the middle, that is called the business layer. Business layer. So now you will have three layers: the user interface, which is the client layer; database, which is the store of data; and third is the business layer. Business layer runs on the middleware. Middleware is a set of programs which are supposed to be in the business layer. So there are many kinds of middle layer available, many kinds of middleware available. One of them is Corba. Corba stands for Common Object Request Broker Architecture. Common Object Request Broker Architecture. So that is the preferred middleware for all those installations which are Java based, because this is very closely linked to Java. Corba is very closely linked to Java. And the second kind of middleware is the .NET. .NET. .NET is from Microsoft. So .NET is also for remoting. It works similar to Verba, and both these middlewares, basically what they do is they create a kind of dialog box will be created for the user to give his information. Once he is satisfied with the information, once he says OK, then the information is serialized, sent to the database, and the output is displayed to the user. So to understand this working of middleware, please think of your banking software. So let us say you have a bank account in SBI, and you click on the link which is for getting the account statement. There is a link like that. So once you click on that, immediately a dialog box opens. This dialog box, there are several questions asked. What are the types of questions? It says, what is the starting date of your statement? What is the ending date of your statement? Starting date, ending date. Then, would you like to see all the transactions, or only debit transactions, or only credit transactions, or both? So you have to select one. Then next it will ask, do you want to see all the transactions or only transactions which are high value, say more than 1,000 rupees? So such questions are asked, and at the end there is a button. There are two buttons in fact, OK button and cancel button. If you cancel, the whole dialog box is cleared and you can fill again. If you OK it, then what happens? This information is sent to the database in serialized form. Serialized form means in a particular serial order, these things are conveyed to the database, and database gives that information again in a serial order, and that is conveyed to the user. So this is how middleware works. Middleware thus avoids errors and mistakes in the data store. So these are the two architectures for data warehouse. The 3-layer architecture is the preferred architecture. So it has certain benefits. The benefits are high performance, lightweight, persistent objects. The objects can be lightweight. They need not be very large in memory size. And they are high performance, lightweight, persistent objects. Then it allows for scalability. Scalability in the sense each tier can scale independently. So let us say database layer, you want to increase the size. It is bound to increase. So when it increases, it doesn't affect the other two layers. Other two layers can remain as they are. And its high degree of flexibility in deployment, because each layer can be separately edited, separately tested, and separately implemented. All that can be done. So these three layers are the preferred method. It also improves the data integrity, because by mistake the user will not be able to cause any damage to the data. He has to fill a form, and that form is sent in serial form, serial order. Reply also comes in serial order, and reply is displayed to the user. So that's how it becomes more systematic. Now in data warehouse, there are three layers. I am not talking of the three-tier architecture. I am talking of three layers now. 3 tiers are different, 3 layers are different. The layers are also 3. So the layers are staging layer, integration layer, and access layer. Staging, integration, and access layer. Access layer. So what is staging layer? Staging layer is that layer where the data from the original database is brought first and parked. This need not be only from one RDBMS. This can be from multiple RDBMS. For example, let us say we are talking about the database for a city. Government deals with cities. So for a city, they will have a database which talks about what are the hotels in the city, what are their locations, what is the number of rooms, and then what are the routes in the city, what is the traffic density on the city. All this will be in the city database. Then there will always be another layer which is from mobile towers. Mobile service providers are many. So we have Airtel, we have Jio, BSNL, and VI. Presently these 4 are there. So all have their base stations, and in each base station a number of calls are received, connected, disconnected, sometimes drop. All that data is there. Then there is data about global warming. So what is happening to the climate, how the warming is taking place, this will be from a different database. So these different databases, each will have its own fields, each will have its own schema. In one database, date and time will be one format. In another database, date and time will be in a different format. Numbers will be in a different format. So, staging layer brings all the things into one place. This is the starting layer for creation of a data warehouse. The next layer is integration layer. Integration layer performs three very important functions. They are ETL, extract, transform and load. Extract, transform and load. So, the critical work is done in the transform part. So, in transform part, all the formats of dates, all the formats of numbers, they are reformatted so that they become uniform. Finally, in the data warehouse, you should have only one format. So, all the dates, all the numbers, all the currencies, they should be brought on a single platform. And once that is done, the third part is the load. Load is loading this entire data onto the data warehouse. So these are the three functions of integration layer. Having done this, now we have to talk about in what view or in what fashion the data will be shown to the user. So for that there are two methods. They are called global as a view, local as a view. Global as a view, local as a view. These things don't change the data. They are only views. They are only two views. So when we say global as a data, we are using a mediator layer there. So the data is taken from the source, it is mediated and then shown in the global format. When we use the local as a view, then we need an adapter or a wrapper software which will convert the data into the view which is local view, which can be accessed by the user. So these are the functions of the integration layer. And the third layer is the access layer. The third layer has many important functions because on the third layer the users can perform lot of operations. The users can perform queries. So they can write a query, get a response and then display it as a report. So for example, let us say there is a database about investments. So every investment will have a closing date. And the managers have to be alert when the closing date of a investment is coming. So here they will work on a query. The query will be, what is the starting date? What is the ending date? So starting date can be anything. You can give a fictitious date also, 111. Because it doesn't make any difference. 111 if you give, starting date is that. But ending date you have to give very carefully. So generally you will give the last day of the financial year as the ending date. So if I give the starting date as 111, the ending date will be 31 3 2026. So once you give like that, the result of the query is generated, and this you can output to the user in the form of a report. That report you can format the way you want. It doesn't change the data. The data in the tables will not change by that. It only changes the report format. So report format, I may require that the investment should be sorted based upon where the investment is. Is it in a bank or in a mutual fund? Where it is. So on that it is sorted, and then within each category of investment some serial number is there. On that basis it should be sorted. So once I give like that, the report is presented like that to the user. So queries and reporting are one thing which the user can do on the database. The user can also do online analytical processing, which is general term for querying, seeing the result of query and reporting. Then data mining also can be done. Data mining is a very important activity. It's a mathematical format, it's a mathematical algorithm which tries to find out the patterns in data. So patterns in data are very important because patterns are not normally visible. They are not normally visible. The data is too voluminous. If you see it on the screen, it goes on scrolling. So you can't make any sense of that. So what you do is you run some mathematical algorithms on this, and then based upon that you arrive at some customer profile, some user profile, and you come to know the preferences of the customer. Such things you will come to know. These things are very important in modern times, because in modern times in the online stores we don't even see the customer. The customer is not visible to us. The customer is only given as a email ID, address and phone number. From that we cannot make out anything about the preferences of the customer. To know the preferences of the customer, you have to generate a profile of the customer, and it is not generated only once. It is generated dynamically. With each transaction, the profile is updated. So data mining is that activity. It is based upon the probability theory. It is based upon finding the patterns in data and all that. So that is the thing which we can do through access layer. And then you can also run some queries through query languages. Like SQL is a query language. SQL is a very powerful language. So with that you can run many queries on a database, and that will give you a lot of information about that data. Now to close this class, I would like to talk to you about the alternative architectures of data warehouse. What are the alternatives we have? What are the various options you have for making the architecture of the data warehouse? So first is independent data marts. Independent data marts. As you know, data marts are specialized, function-oriented parts of the data warehouse. So, for very new companies which have not yet gone for a regular data warehouse, independent data marts are the easiest solution. So, for supply chain management, they will have a data mart which will contain only the data of supply chain management. For financial management, they will have a data mart that will contain only that data which pertains to the finance field. Like that, various kinds of data marts will be there. This is a very simple solution, but this is not an ideal solution. Why it is not ideal? Because in this, the independent data marts do not talk to each other. They do not share data. Sharing data is very important. Look at it. Let us say we are talking of marketing data. In marketing data mart, there will be a table on orders booked. Orders booked. In orders booked, there will be a column order booked by. So what name you will enter there? You have to enter the name of an employee. That employee, if you enter the name separately each time, your spellings will always change. Spellings will always change. So at the end, when you want to run a query, you will get outliers, you will get points which are not in the main frame. So what is the solution for this? The solution is only one. The HR database which contains the information about employees, that should be accessed. From there I should pick up and give that employee ID as the order booked by. Once I do that, it becomes correct. So independent data marts don't allow you that facility. It is a very simple solution, but not a perfect solution, because in this, the independent data marts just don't talk to each other. They don't share data. As a result, the data becomes outdated and erroneous in due course. The second method, the second alternative architecture is data mart bus. Bus here is a means of providing communication among the software entities. So all the data marts, they are on a data mart bus. The bus links to all the data marts, and then they are able to share the data. Seems to be alright, but this is not also an alright situation, because the format of data in different data marts is bound to be different. The dates format will be different, numbers format will be different, text formats also may be different, currencies may be different. So this is also not a very perfect solution. It's only a partial solution because this allows the data marts to talk to each other, share the data, but they are not really integrated with each other. The third alternative architecture which is alternative to this is hub and spoke. Hub and spoke. Hub and spoke is the most rigid one. Here you have a hub which is a central data warehouse, and so many spokes are there which function as independent data marts. This is a very good solution because here the data marts are all integrated, their formats are also common, and the only drawback of this is that in this you have to really have an integration layer first. That integration layer should do the extract, transform and load. So that additional work is to be done. With that we are able to do hub and spoke. However, there is one disadvantage also. The view which is provided in hub and spoke, that is a global view. It doesn't show local view, it provides only the global view. So except for that, it's a very powerful solution. The fourth alternative architecture is centralized enterprise data warehouse. This is the complete data warehouse which is integrated properly. Global view is there, local view is there. So this is the one which you can think of. And the last is the federated architecture. Federated in the sense, this is for those companies which have a legacy. When legacy is there, the data will be in so many different systems, they will find it difficult to integrate all the things. So when they have data in so many different functions, so many different systems, to bring all the data into a centralized data warehouse is quite difficult. And there the federated is the one which is preferred. I can give you an example of the federated data warehouse. You know that a few years ago, State Bank of India had merged all the state banks together. That means State Bank of Hyderabad, State Bank of Patiala, State Bank of Travancore, they were all merged with State Bank of India. Now each of these banks had their own systems, their own softwares. This is the need for federated one. So when such things are there, federated data warehouse is necessary. So any questions on this? Right, thank you for attending today's class. Thank you.